Hello, my blessed and my dear geometry standard students. I missed some of you today, but I trust you'll be able to look at this and be somewhat ready or very ready for your quiz tomorrow. You know it was coming. Anyway, I'm going to go ahead and do a couple of these practice questions. One of them was this one, which is before us, and this is where we had to do a proof. And it says number 5, write a proof. And this is easy, very easy. Say it with me, this is easy. So it says here that SO, segment SO is congruent to segment LU. So the first thing to do, just make a mark. SO is congruent to LU. And then things unfold to you as you can see the marks. That's all they give us. But here's a question, can we make any other marks? And I trust you're just really rearing to go to say, yes, we can mark the reflexive. That's the reflexive right there. I should give it 2. Let me try again. 1, 2. So once we've made the mark, we have it before us. This is the hypotenuse. The hypotenuse is the side opposite the right angle. So the hypotenuse is marked and a leg is marked from each triangle, from the upper and from the lower. So that's going to be our final reason, hypotenuse, leg, congruent. So you can just keep this in mind. That's where we're going. Again, hypotenuse, leg. So doing the proof, the first step is to use a given. So we go SO, segment SO is congruent to segment LU. What's the reason? And I can just hear a thunderous shout of given. That's what it is, given. What else? So we've taken care of SO, segment SO congruent to segment LU. So that's the leg. I'm just going to put a leg here. So we've taken care of the leg matchup. Now we want to take care of the hypotenuse matchup. Here it is. SU from the lower triangle congruent to SU from the upper. So we write SU congruent to SU. Reason, and I hope I can hear, almost like a choir saying, reflexive. Reflexive property. We've done that again and again. That takes care of the hypotenuse matchup. You say, what do you mean? This is the hypotenuse from the lower triangle. SU is also the hypotenuse from the upper triangle. So that's why it takes care of the hypotenuse. So we do have hypotenuse leg accounted for. So therefore we can now make our conclusion. Triangle SOU, which is the upper one. SOU. Notice I'm starting here, then I'm going to the right angle, then I'm ending up here. So I'm going to start here. It's going to be congruent to triangle ULS. And this is going to be by what? The hypotenuse leg congruence. We knew it was coming. Hypotenuse leg congruence. But please be aware that it doesn't always have to be hypotenuse leg. It depends on where the marks are. One mark is here on the hypotenuse. One mark is on the leg for this. Similarly, one mark is on the hypotenuse for the upper triangle and the other mark is on the leg. That's why we did hypotenuse leg. All right. So that would give you the flavor of that one. Let me go back to the beginning, which says, write and ponder a verse which Christ in his mercy gave us related to one specific congruence. And this should be about, maybe we could just say congruence, maybe I could just say congruence with our Father. And you know the verse. It says, therefore be merciful, just as your Father also is merciful. He wants our mercy to be congruent to the Father's mercy. Okay? So therefore, be merciful. Just as your Father also is merciful. Just as your Father, and by Father here Jesus meant God, your Father also is merciful. Okay, rehearse that with me. Therefore, be merciful, just as your Father also is merciful. Only 10 words. One more time. Therefore, be merciful, just as your Father also is merciful. What else do we have? What is the difference between angle, angle, side, and angle, side, angle congruences? Well, angle, angle, side has two angles next to each other and then a side. Has two angles next to each other and then a side. That's angle, angle, side. How about angle, side, angle? You can see the side being the peanut butter between the two slices of the bread, which I could call the angles. So an angle, side, angle, angle, side, angle also has two angles, but has the side included or in between. But this included would be a nice way of saying it, included between the angles. Angles. Falling asleep here, class. I'm sorry. All right. How about the statement of the angle side angle congruence? Well, it's a nice one to do on the heels of this angle side angle business. So what is that all about? Angle side angle, the congruence states that if two sides and an included angle from one triangle, so the angle side angle congruence is a statement of congruence or equality between two triangles. So if two sides and their included angle okay, I'm just going to use some symbols here. Included angle from one triangle so that's the heartbeat of the issue here. Again, two sides and the angle between it. So that's what this is talking about. The two slices of bread would be the two angles. I should say not two sides, but two angles. Sorry, two angles because it's angle, angle, and their included side. From one triangle is good. This is good. From one triangle are congruent. I'm just going to use the symbols here to corresponding or matching parts. From another triangle then the two triangles are congruent Those triangles are congruent. This is going to be by what is called the angle side angle congruence. So you can rehearse that with me. If two angles and they're included, not angle, but side from one triangle are congruent to corresponding parts from another triangle, then the two triangles are congruent by the angle side angle congruence. Now we're going to actually use it. So watch carefully. Is it possible to write a congruence between the two triangles shown in questions 4 through 6? If so, write yes, and B, write the congruence. So you look carefully at the triangle, lower triangle, and the upper one. You see this one has two angles that are congruent to two angles here. But is there anything we can mark? Say yes. We can mark the reflexive. So what can you see? Angle, angle, side. So you should write a resounding yes here, and then angle, angle, side congruence. How about this one? Always look to see what you can mark before you answer. So we can definitely mark something as we compare the left triangle with the right one. We can mark the vertical angles like that. So as soon as we mark it, we notice that we have side angle, side from this one, congruent to side angle. Uh-oh, we're missing a side. So we're going to have to say a no on this one. Finally, in this grouping, we've got two angles from the lower triangle, congruent to two angles from the upper one. This and this. But we can also mark the reflexive. So that gives us an angle, side angle from the lower, congruent to an angle, side angle to the upper. So for this one, it would be also a yes. And the congruence would be angle, side, angle. Congruence. All right, one more, and that would be all. Let's take a look at one more. That would be the isosceles triangles and the equilateral triangles. All right, here comes the equilateral triangles. Once you see a triangle with three angles the same, you say, oh, well, the sides must be the same. In addition, each angle must be 60 degrees once it's equiangular or equilateral like this. So in order to find x, is it find x in each of the figure below, we'd have to say that this side length, 5x minus 7, is the same as this side length, x plus 17. 5x minus 7 is equal to x plus 17. And that's how we'd work it. All right? The algebra I'm sure you can do. Subtract x from both sides. You get 4x minus 7 is equal to 17. We add 7 to both sides. We get 4x equals 7 plus 17 is 24. And then divide by 4, we get x we divide by 4. I'm sorry, I'm falling asleep. We get x equals 24 divided by 4 is 6. So that is it for the equilateral triangle. And let's go to this one, number 12. This one is also equilateral. The three sides are the same. So therefore, the three angles have to be the same. What would be the measure of each angle? If they are the same and they add up to 180, each one would have to be 60 degrees. Indeed. So, what's the setup? 9x minus 3 equals 60. That's the setup. We simply add 3 to both sides. We get 9x equals 63. Divide both sides by 9. We get x equals 7. And finally, with the isosceles triangle, once you see a mark like this, that means the base angles would be the same, and the setup would be 5x equals 70.